The topic for today is geometric series. Yesterday was arithmetic series. Really, the only difference between what we did yesterday and today is the word arithmetic versus geometric, and then, of course, a different formula to go with it. Let's check it out. Geometric. Quick reminder of what does geometric mean? Means that there's going to be a constant multiplier from one term to the next. And remember, the word series means sum, means add them up. So if I want to have a geometric series, well, first let's talk geometric sequence. It would go something like this, like 2, 6 times 3 is 18 times 3. Oh boy, I should have picked an easier one. 36, 54. This is a sequence. This is a sequence, and if you want to turn it into a series, all you have to do is just put little plus signs between it and turn it into a sum. Your book in our notes is going to call this a partial sum. A partial sum means that you're just finding they'd call it the fourth partial sum. So it's not the sum of the entire series, all of it, but just part of it. There's a proof for the formula. It's probably not worth going through. It's in your book if you want to check it out. Otherwise, we'll just save that for AP Calc. So it goes like this. You're going to have the sum of it. You're going to see it in a couple different ways. Usually, it's going to go with the first term in front, g sub 1 in front. And then you have 1 minus r to the n on top and 1 minus r on bottom. There's really not any simplifying that can be done, so I guess I should have just written it in this over here. Sn equals g1, 1 minus r to the n, and 1 minus r. Just so we're clear, we got your first term here. You have your ratio here. That's your multiplier from one term to the next, and then n is going to be your number of terms. All right, I'll try one, and then you can try one. This is that same summation notation from before, so this means add them up. This is 12 terms, and then here you have an explicit formula on how you can find each term. So if you want the first term, all you got to do, just plug a 1. 1 minus 1 is 0. Anything to the 0 power is 1. 32 times 1 is 32. It's going to be my first term. Or maybe you just recognize this as your explicit formula for geometric sequences. Plus your second term. 2 minus 1 is 1. 1/4 to the 1 is 1/4. And 1/4 of 32 is going to be 8. Third term. Plug a 3. Or maybe you can just see the pattern that we're multiplying by 1/4 over and over again. So it's going to go plus 2. A fourth of that would be 1/2. And you get the idea all the way until we get the last term. Well, for your arithmetic sequence, we needed to find the first term, the last term, and how many terms. This one you actually don't. You need your first term, which we know is 32. And then you have 1 minus your multiplier, which we said is 1/4 to the power of the number of terms. So the number of terms in this case is going to be 12. And then 1 minus your multiplier on bottom. After this, it's really just making sure you can keep it straight on your calculator. You just need a heads up. So we're going to go 1 minus 0.25 power 12. Make sure that 12, that power is only on the 0.25, not the whole thing. And then we'll divide by 1 minus 0.25. Like I said, make sure these just go together. Like 1 minus 0.25. Otherwise, it's going to go divide by 1, done, and then subtract 0.25, and that's not what you want. You want to divide by that whole thing together. You got that, and then we'll go times 32. So you get 42, and we're just going to call it 0.6 repeating. So 42.6, and you got it. All right, give it a pause. See if you can figure out the next one. All right, you can see right here your first term is going to be 0.25. You have 1 minus your multiplier here. It's kind of a weird one, which is a negative 2. Careful on this one. Power 14 over 1 minus a negative 2. Parentheses are really helpful just to make sure the power goes only to the number, the multiplier, not to the whole thing. So we'll try it. We'll go 1 minus a negative 2. I personally don't prefer to try to type this whole thing in all at one time. You can try it if you want. I've seen lots of people make mistakes that way, but it's up to you. So there's your numerator. On bottom, I'm going to have 1 minus a negative, so that's plus, so divided by 3. And then we'll go times 0.25. And so we get a negative number here of negative 1365.25. You get the idea. After that, it's all story problems to see if we understand what's going on. So you try this next one, and then we can check it in just a second. All right, each year an investment property grows by 6% in value. So I should note that it's the value that's increasing right here. So in year one, it increases $33,000. So what's your rate of growth? Well, it's obviously 6%. So 0.06. Maybe a better question would be, what's your multiplier? If I want to grow by 6%, well, if you multiply by 0.06, it's actually going to get smaller. So we need to throw a 1 in front of that and multiply by 1.06. How much does it grow in just year two? Not the sum of the first 2 years, but just the first, just year two. Well, you can just click this a couple times, or just go times 1.06 twice, or you can use your explicit formula. If you remember, it goes like this. You write out your first term, which is 33,000, and then you go times 1.06 to the power of n minus 1. N minus 1. In this case, if we want just year 2, that's going to be a 2, so we'll go 33,000 times 1.06 power, and we can just go power 1. You got it. So here's year 1. So we got it. We got 34980, and you got it. How about in just the 8th year? Once again, all that is, that's an explicit formula. 06, and then you have 8 minus 1. So if you want just the 8th year, type that in. We got 33 times 1.06 power 7, and you've got it. So that's not the value of the property, that's the increase. So how much will the value increase in the first 10 years? That's the sum of the first 10 years. So if we want all of those years put together, here's what we want. You want your first term, which is 33,000. And we have 1 minus your multiplier, which is 1.06 to the 10th power. 1 minus 1.06 is going to go on the bottom. After that, it's all making sure you can keep it straight. So let's try it. I'm going to go 1 minus 1.06 power 10. Get that for numerator. Divide by 1. Oops, put it in parentheses. 1 minus 1.06 on bottom. Boom. And then times, you can see right now if it asks you how many times bigger is it going to be, I can see that it's going to be 13.2 times bigger, because I'm going to take that number and go times 33,000 right now. So this number here, this 434,966.23 is the total increase over the first 10 years. All right, let's see. One last problem, and then that will be it for this. All right, let's see if we can figure this out. Here's a geometric sequence that I want you to be able to add up. So let's figure out what we need. First of all, if I'm trying to find the sum, I need the first term, which is 16. You need to have, we're going to go 1 minus the ratio, and it's really not obvious just by looking at the numbers what the ratio is. If you ever want to figure it out, just pick two terms that are next to each other and divide them. So if we go 20 divided by 16, you have a multiplier of 1.25. Well, let's make sure that that multiplier actually works. We'll go 20, and I'll use that multiplier, times 1.25. Hey, look at that. I got the next one. And we could continue finding more terms just by multiplying by 1.25. So I got 1 minus 1.25. 1 minus 1.25. The problem here is I need to go to the power of how many terms there are, and that's what I don't know what that is. Well, just like before, anytime you don't know, you can just go back to your explicit formula. Your explicit formula, remember, was this, was Gn equals G1 times R to the n minus 1. So what we can do is just start filling this out. So right here, the term that I want is this guy here, is 3125 over 64. You can write it as a decimal as you want, if you want. If you prefer not fractions, that's fine. This is going to be equal to my first term of 16 times 1.25 to the power of n minus 1. And now we just have to solve this. Well, this goes all the way back to first semester using logarithms. So we're going to keep this thing off to the side. And let's just, in order to use a logarithm, you have to get rid of what's in front. So first I'm going to figure out this, what it is as a decimal. So I'll go 3125 divided by 64. Make sure I got that right. Yep. So that's 48.8. Now I'm going to divide by 16. I'm going to put that number, I'll write down 3.1, but I'm going to keep this unrounded number on my calculator. So I have 3.1 is going to be equal to 1.25 to the n minus 1. Now, anytime you want an exponent to not be an exponent anymore, that's what the log does. So we'll say log this side. We'll log this side. When you log it, you can say, hey, you, down in front. That means the entire thing goes down in front. So let's see, let me rewrite it. I got log 3.1 is going to be equal to n minus 1 log 1.25. The thing that we never forget is that this is just a number and it's multiplied. So when a number is multiplied, you just divide it away. So let's go log. Now I've been writing 3.1, but I'm going to now use answer so that I use the unrounded value on my calculator. So log answer, divide by log 1.25. Got it? Hey, you get 5. Maybe I could have just figured that out. There's only one term missing, so maybe I could have just figured that out by clicking buttons, but not all of them are that easier. So I have 5 is going to be equal to n minus 1. Add 1, so it's actually going to be the 6th term. There's a couple terms missing. So n is going to be equal to 6. Now I can go back to my formula, plug a 6 right there, and figure out the sum of this series. So I'll go on here, go 1 minus 1.25 power 6. That's the numerator divided by, in parentheses, 1 minus 1.25, boom, times 16. You can see that my answer is going to be 11.3 times bigger than my original amount that I had. So there you go, you have 180.14. Hopefully that was helpful.